this is Mira and welcome back to my channel. Today we will solve the very first numerical on rectilinear motion. We will discuss all the possible problems under rectilinear motion topic and solve a numerical on uniform acceleration. A car is traveling at constant speed of 45 km per hour. At 10-meter distance ahead of the car, a truck is also driving at the same speed. Unfortunately, the driver is missing. Now suddenly our imaginary truck driver applies the brakes, so the truck started decelerating at constant rate of 2 meter per second square. 2 seconds later, driver of car realizes that the truck is slowing down and applies his brake too. He just manages to avoid a rear end collision. Determine the constant rate at which the car decelerates. This is the problem statement. Now before we begin, let's see the type of problems we may face in case of rectilinear motion. There may be problems of variable acceleration, or let's say no uniform acceleration is mentioned. They are simple problems and they can be easily solved using differentiation, integration and some general equations. Apart from these general equations, there may be two types of situation. First is problem of uniform acceleration. These are the equations for this case. The derivation of all these equations are discussed in the previous video. If you want to go through it, I will share the link in description box. These equations will be used if only acceleration or deceleration is the point of concern. Second is erratic motion. In these problems, the motion parameters are not continuous. In a single problem, there will be acceleration, deceleration, constant speed, etc. For this type of problems, xt, vt or at graphs will be plotted and solutions will be derived from graphical methods. Now in given problem, both car and truck are traveling at certain speed first and then decelerate constantly. We are interested in deceleration only. What distance they have traveled before that is not important. So we will use the equations of uniform acceleration here. Now let's see what is given data and what is to find out. The initial velocity of car and truck is given, that is 45 km per hour. Initial distance between car and truck is 10 meter. The truck is decelerating at a rate of 2 meter per second square. So acceleration of truck at is minus 2 meter per second square. And acceleration of car AC is to be determined. So first we will convert the initial velocity in meter per second units, as all other parameters are given in meter and seconds and not in kilometer or hour. So 1 kilometer is equals to 1000 meter. So multiply 45 by 1000 and 1 hour is equals to 3600 seconds. So divide it by 3600. So now our initial velocity is 12.5 meter per second. Here in given problem, if we take car's position as a reference point and add the distance between car and truck as initial position of truck, the total distance they both cover is same. Because at final position, the car just managed to avoid the rear end collision and the initial gap between vehicles is filled. So total distance travelled by truck xt is equals to distance travelled by car xc. Also, the car driver applies his brakes 2 seconds later. So he will have to decelerate at faster rate. But still, at some point near final position, the velocity of both vehicles will be same, as the car cannot jump over truck. So final velocities of both vehicles Vt and Vc are equal. So let's use the equation of distance x and any one equation containing final velocity v. For truck, as we discussed, the initial position is 10 meter, that is the distance from reference point car. Initial velocity of truck is 12.5 meter per second and acceleration is minus 2 meter per second square. For car, the initial position is 0. The car driver applies brake after 2 seconds. So he will have 2 seconds less than truck driver to stop. So time is t minus 2. AC is to find out and again time is t minus 2. But during 2 seconds before applying brake, the car will continue driving at initial speed. So we have to consider the distance it will travel during those 2 seconds also. So it is equals to initial velocity 12.5 multiplied by time 2 seconds. Here plus and minus 12.5 into 2 got cancelled and final xc is equals to this equation. But there are two unknowns AC and T in this equation. So let's see if we can find out any one of them. So other equation available is for final velocity. For truck, final velocity is Vt, initial velocity V0 is 12.5 and acceleration is minus 2. Similarly for car, final velocity is Vc, initial velocity is 12.5 and time is t minus 2. Now Vt is equals to Vc. If we cut 12.5 from both sides, we get AC in terms of time t. Let's put this value in equation of xc. So we get xc equals to 14.5 t minus t square. Now again xt is equals to xc. So we get t equals to 5 seconds. And by putting this value in equation of AC, we get AC equals to minus 10 by 3 meter per second square, which means that the car has to decelerate at a rate of 10 by 3 meter per second square.